and we will measure. It's a 9. Now it's 9 o'clock. So it's 9 o'clock. It's 9 o'clock. And direction is east, and the slope is 25 degree. 25 degree. 25 degree is the best angle in Paraguay. So we will start to measure face to the east, and the contact the angle is like the roof, 25 degree. So now you can measure the current is 0.6 amp. 0.6 amp. So 0.6 amp. Right amp, 0.6 amp. And we will measure the voltage. Hello everyone. Today we will do solar power testing at Asunción. This is my dormitory, and we will do the test here. Today we will do the test of the solar glass, of my solar glass, and this we will measure the solar power, and this is our solar glass. We will do the test today, and the solar power is you see it can generate solar power like this. This is the sunshine. And this is the sunshine, and then this is solar power. And the location is in my dormitory. It's Asunción. So today is a sunny day, so we can do the very good solar power testing. You can see the solar power is very strong. So we will do the test. Maybe someday we can apply on the roof skylight. To do the solar power test, you need to very good app. Please download from app from your software. One is to measure the slope, and this software is very powerful because it can measure the slope. For example, now is the slope of the table. Yeah, this is the slope. You may could look, is a zero slope, and if you put here, you will put here, you can measure the slope. You can measure the slope of the solar panel, solar glass. So it's very important to download this app. And the next app is to measure the direction. So it's very important to you need to measure the direction. Yeah, due to you need to know what is your solar panel the direction. So please you need have this kind of two app. Repeat again. One app is a download to measure the direction, and another app is to download to measure the slope. Yeah, the slope. This is zero slope, and the slope should be 20, and so it's a measure the slope of the solar panel. So please you need to have these two important app. Now we start to measure the solar power, of my solar glass. As well, you also need to prepare the recording. For example, the record is a solar power test. Today is 2020, and May 16. The location is Paraguay, Asunción. The weather is sunny. Today is a sunny day, so almost not clouded. So it's very good to do the solar power testing. And also you can look, the solar power is very strong. It's very strong. And so the sunny day is a sunny day, and we will do 3 kinds of tests. One is a time effect. To do the solar power depends on the time, and the direction effect. The solar power depends on the direction, north, south, east, west, and also the slope. The slope is the angle, the angle of the solar panel, and we will measure the slope effect. And also we will measure the current from the machine. We will measure the current, the voltage, and then the power. And also we will measure the sun intensity. This is the facility. It can measure the sun intensity. The sun intensity is the energy from the sun, and the unit is watt. The unit is watt. So, for example, when we face to the sun, and you can measure the sun intensity is almost up to 1000. It's 923 watts per square meter. So this is the sun intensity in Paraguay. It's very high. We will start to connect how to measure the solar power. The first of all, you need to prepare a string to connect to the measurement. So here we press the connect here, and another we need to plug here, and we adjust to the voltage, and we turn on the is a no voltage, because we don't have a solar power. So we want to connect to the this is the wire from the, this is the wire, and we will connect the end, and we connect, and you will find here is minus. That means it's a arrow. So you need to okay. You look now the solar glass face to the sun. Face to the sun. The solar glass face to the sun, and it will get a very good current, 0.7 amp. And if we let it become horizontal and look like horizontal, and you will look the current is reduced to 0.3 amp. Yeah, so you can see the difference. Is the current is different. And also when we face the sun, and the voltage is almost 20, is 19 volts. And if we put it horizontal, look like this, look like this, and you will look the voltage become 18. Not so many difference, so you will know the slope of the solar panel. Most of the difference is in current and not in voltage. Not in voltage. Yes. Now we will start to do the test. Please, everybody, please. But this is not the best angle in your country, because I know in your country the best angle is like a 25 degree. So we need to adjust at least to 25 degree. Yeah, we need to adjust. Yes, when I put, yeah, can you look the 25 degree? 25 degree. When we put something at the bottom, and we can get 25 degree. So 25 degree is look like on the roof. So now we will measure the 25 degree. 25 degree is the best slope for the roof in Paraguay. So when you put the solar panel or solar glass on the roof, the 25 degree is the best. It's the best angle on the roof according to your latitude. In Asunción in Paraguay is 25 degree. So we will do the test. One of the tests is the solar power, and like on the roof in Paraguay here, and then we will put the solar panel and look like this. Go. Another test angle is almost 90 degree, because we will put the solar panel on the vertical window. Look like this. So this is our second test to do the solar, to measure the solar power on almost 90 degree. It's a vertical. It's a vertical, so it can simulate on the window for high-rise building or at the house. This is our second test. And we will also have the test on horizontal. It's a 0 degree. It's look like this solar panel is put on the ground or put on the horizontal roof. Something like some factory, in the factory, or some roof is a horizontal roof. Look at this. This is the building, or on the skylight. You mean you look the skylight is like a horizontal. So the third test, we will do the test for horizontal. Many times when we apply on skylight, so it should be 0 degree. Now we just do a very simple test. For example, the solar glass now is face to the east, so you can see the sunshine, and it's face to the east. So when we change the angle, and you can look the difference in the amp, in the current. When I adjust to vertical, you look, and the voltage is the amp becomes small, and if I change the angle, and the voltage become larger. you will look become larger. And if I continue to change the angle, yeah, I continue to change the angle, you will look the difference of the voltage. Yeah, become 0.6. Yeah, I try get is a zero, is a horizontal, the horizontal, and the current is a 0.5 amp, and we change the angle is a become larger, 0.7 and 0.7, and it become vertical. Yeah, so face to the sun is a 0.7, and you will put the to horizontal is become small, and again is bigger, and the vertical is also 0.7, and when we change to the south, so you will look the voltage, the south, because at the south, the voltage, is not face to the sun, so the current become small, because it's not face to the sun, so reduced to 0.1. But when we let the horizontal, so you will look horizontal, look like this. It's horizontal. You will look the current is go back to 0.5. That means for the solar panel on the zero is a horizontal, like you put on the skylight, is a no relation to the direction. Okay, so now we will change to the west direction. Change to the west. The west direction will look like this. So we will also measure the current. When the solar panel is a back, not face to the sun, but it still have power, but not 0.7, just only 0.1, because it's not face to the sun, but back to the sun. Okay, so we change to horizontal. So you will know it's also back to 0.5 amp. 0.5 amp. Yeah, even is face to the west. So you will know when we put the horizontal is not related is to the direction. So put on the skylight is the best choice. Okay, so now we will change to the direction to the north, and this is the best. This is the best direction in Paraguay. So you will know, when the vertical, the power go back, the current is go back to 0.4, and then when we change to vertical, it go to small 0.1, and if on the roof is go back to 0.4, and change to the angle is also is go back to 0.5. So the conclusion is for horizontal is not related to the direction, and in the morning time, during the morning time, the best solar power is at the east. The second is at the north. But during the afternoon, the best should be at the west, and the second should be south. Should be north. Yeah. So I measure this, and the time now. The time now you may record. The time now is 9:42, and I will show you the time. Now is 9:42. 9:42 is the now. Is 9:42, and the voltage and the current 0.5 of the solar glass. It's the direction. Yes. Let's look here, and we will measure. It's 9. Now it's 9 o'clock. So it's 9 o'clock. It's 9 o'clock. And direction is east, and the slope is 25 degree. 25 degree. 25 degree is the best angle in Paraguay. So we will start to measure face to the east, and the contact the angle is like the roof, 25 degree. So now you can measure the current is 0.6 amp. 0.6 amp. So 0.6 amp. Right amp, 0.6 amp. And we will measure the voltage. Now we will start to the test. It's face to the east. Sun is over there. And now it's 10 a.m. We will measure east. 0, 25 degree, 90 degree. So it's horizontal 0 degree. So you can measure the amp 0.5. We measure 25 degree. Current 0.7. We measure 90 degree. Current 0.7. We measure 90 degree vertical. The voltage 18.7. 18.7. 25 degree voltage 18.9. 18.9. We measure the horizontal 0 degree voltage 18.6. 18.6. We measure 0 degree horizontal voltage 18.6. 18.6. Now measure face to north. Face to north for 25 degree voltage 18.6. 18.6. Horizontal face to north voltage 18.7 or 18.8. 18.8. 90 degree vertical face to the north voltage 16.9 or 17 vertical face to north current 0.2 amp. 0.2 amp. North face to north 25 degree current 0.7 0.6. Horizontal, face to north. Current 0.6. Now we are doing face to west. Current 0.2. Face to west 25 degree. Current 0.2. Face to west horizontal 0 degree. Current 0.6. Back to the sun. Face to the west. And back to the sun. The current 0.2. Current 0.2. Face to the west. Back to the east. Face to west. Back to the east. Face to west. Vertical. The voltage 17.6. Horizontal, face to west. Horizontal, face to the west. Voltage 18.45. 18.4. 25 degree, face to west. Voltage 17. Voltage 17. To the south. 25 degree. Voltage. Oh, sorry. To the face to south 25 degree roof. The voltage is 18.5. 90 degree vertical, face to east, face to north, face to south. 90 degree vertical. The voltage 18.1 and 15.1. Vertical, face to south. Voltage. Horizontal, face to south. Voltage 18.9. The current horizontal 0 degree, face to south. The current 0.6. The current 25 degree roof. Face to south. The current is 0.5. The vertical, face to south. The current 0.1. 25 degree. Face to south. 25 degree, and the current 0.5. And solar intensity is you need to measure the solar intensity instrument. It's vertical to the surface of the solar panel. So for example, it's 25 degrees. So when you measure the solar intensity, you should be vertical to the surface of the solar panel. So now you can measure the solar intensity. For example, it's 480, and then you can measure the current is 0.5. So please be assured the vertical, when you measure the solar intensity, you should be vertical to the surface of the solar panel. This is the final result of the testing in 10 a.m. in the morning.